It's a matter of great honor to be invited to give this Krishna Warrior Memorial Lecture as a homage to this good soul. It's very thoughtful and kind of the Astro community to commemorate a lecture series in honor of this gentleman, in memory of this gentleman who had such pristine passion for astronomy. I remember him as someone who was a science ambassador in the purest sense. So it's really a nice gesture that an initiative has been done to commemorate him through a lecture series, which he has enjoyed a lot in his lifetime. So the first couple of slides, I'm going to talk a little bit about him, and then I'll move towards the main lecture. അദ്ദേഹം ഒരു അമ്മാമൻ മെൻറ്റർ എന്നുള്ളതിൻ്റെയൊക്കെ ഉപരി എൻ്റെ ഒരു സുഹൃത്തും ഗുരുവും വഴികാട്ടിയൊക്കെ ആയിരുന്നു. അദ്ദേഹം എഴുതിയിട്ടുള്ള ബാബു എന്ന പേരിൽ എഴുതിയിട്ടുള്ള ധൂമകേതുക്കളുടെ ലോകം എന്ന് പറയുന്ന ഒരു പുസ്തകം പരിഷത്ത് പബ്ലിഷ് ചെയ്യുന്ന 1986-ലാണ്. 1986-ത്തെ വളരെ പ്രശസ്ത ഹാലി ധൂമകേതു നിരീക്ഷണവും അതിനെക്കുറിച്ചിട്ടുള്ള ബോധവൽക്കരണവും ഒരു ശാസ്ത്ര പ്രചാരകൻ എന്നുള്ള നിലയിൽ അദ്ദേഹം അന്ന് തന്നെ ഒരുപാട് കാര്യങ്ങൾ ചെയ്തിട്ടുണ്ട്. ആൻഡ് ദിസ് ഈസ് ആക്ച്വലി എ പിക്ചർ ഫ്രം 1998. I still remember him talking about this famous Leonid meteor storm in 1998. And I still remember looking up the sky because of his exciting conversations. And I managed to see some meteors in the sky. And that eventually sort of sparked my interest to specialize in meteor science and ultimately in becoming the first professional meteor astronomer from India. So I'm deeply indebted to him and very grateful to his wisdom, advice, thoughts, guidance, and so on. And whenever I clearly know that he was interested in all facets of astronomy, all areas of astrophysics, but he definitely had a special interest in the field of comets and meteor showers. So that's the reason why I chose this topic. And right from my childhood, I remember him being very fascinated about comets and meteor showers. ഈ ധൂമകേതുക്കളുടെ ലോകം എന്നുള്ള പുസ്തകത്തിൻ്റെ പിന്നീടുള്ള റീപ്രിൻ്റ് ഇന്നുണ്ടോയെന്ന് എനിക്കറിയില്ല. പക്ഷേ നിങ്ങൾക്ക് ആർക്കെങ്കിലും അത് വായിക്കാൻ പറ്റുവാണെങ്കിൽ നിങ്ങൾ തീർച്ചയായിട്ടും വായിക്കണം. മലയാളത്തിൽ ധൂമകേതുക്കളെക്കുറിച്ച് എഴുതിയിട്ടുള്ള ഏറ്റവും നല്ലൊരു പുസ്തകമായിട്ട് നമുക്ക് പറയാവുന്ന ഒരു വർക്കാണത്. So he had this magic of teaching and inspiring youngsters to astronomy and space science and so on in a very simple and lucid way of explaining things. And he was able to teach at all levels, all age groups, all backgrounds and so on. എനിക്ക് പലപ്പോഴും തോന്നാറുണ്ട് വളരെ ദുർലഭം ആളുകൾക്ക് കിട്ടുന്നൊരു സിദ്ധിയാണത്. അദ്ദേഹം ആ കാര്യത്തിൽ വളരെ ഒരു ഗിഫ്റ്റഡ് ആയിട്ടുള്ളൊരു ടീച്ചറായിരുന്നു. And his passion and patience for late night observations, I'm sure most of you sitting here would know, because some of you would have probably accompanied him for some late night observations, and he was very happy to sacrifice his sleep for inspiring youngsters and motivating them into science. And unlike many science educators and many professional scientists I see these days, he was not a super specialized, narrow-minded scholar sitting in some crazy ivory tower. He was someone who had deep interest in all areas of science, and almost he had a curiosity about everything to do with nature. So I like to think about him like more of a Renaissance man who had an interest in anything to do with science and logic and philosophy and academic debates and so on. So he was not just restricted to some very specialized area of astrophysics, as it were. In many ways, I think he was a kind of a raw genius and a science ambassador to a lot of people of all age groups. And he pursued pure science just out of sheer passion, because his professional work or his official work has got nothing to do with astronomy at all. He was working mostly in engineering related projects in CDAC and ER&DZ and Keletron and so on. So he didn't do science or astronomy for any official promotion or anything to do with work. So it was his hobby, but sometimes his hobby eclipsed in such a way that it became part of his life. So he was untouched by any greed for money or power or position or fame and so on. One of those rare gems whom you see in this world, away from all these sort of worldly greed and pleasures and so on. So I think most of the people who knew him closely would agree with me in saying that he was a man with almost zero ego. And I think that was largely driven by his philosophy that we humans are in that special. Moreover, even life on Earth isn't that special. So that was his underlying philosophy. And I'll start my talk taking this thread from his philosophy, asking the question as to, are we really that special? Is Earth and is our own life that special? So is our planet alone in the universe in terms of life? So let's just look at this objectively. If you look at the whole universe, the present estimate says there are about 100 billion galaxies. And there are about 100 billion galaxies, 100 billion stars for every single galaxy. So the total number of stars in the universe is roughly about 100 billion into 100 billion, which is about 10 to the power 22. And if you assume, let's say, one planet per every stellar system, we are talking about 10 to the power 22 planets in our whole universe. So we are talking about this huge number, staggeringly large number, which you can see on the slide. So it's not very logical to believe that only one out of so many zillions of planets can have life-sustaining conditions. Even if 1/1,000,000th of a percentage of this number could sustain life, still it's going to be a considerably large number. So it's a good reason to believe that our planet Earth isn't that special after all. So it's a good way of trying to understand our own place in this universe. So studying exoplanets is something which fascinated him in his later years because there are a lot of new discoveries, very exciting things coming out of this field. So just to give you a brief idea, exoplanet is a planet which orbits around another star. Any planet outside our solar system is an exoplanet. So it's as simple as that. Here you see a nice picture of Proxima Centauri, which is the nearest star to us other than the sun, after the sun. So as most of you know here, humans have explored our own solar system in different ways, in different size scales. So Voyager missions actually gave us a great idea about different planets and its moons and so on. The Rosetta mission some years back landed on a comet. Hayabusa mission explored asteroids. The Leonid's air survey looked into Leonid's meteor shower. So there has been various exploration missions from our side to explore our own solar system in different size scales, right from planets to as small as meteors. And it's also important to stress the fact that India did our own excellent missions like Chandrayaan and Mangalyaan and so on. And we have been doing a lot of exploration missions. And these days, it's not just about our own solar system. There are a lot of very interesting exoplanetary science missions happening. And the present record is we have about 5,000-ish exoplanets discovered so far in about 4,000 planetary systems. And most of it is from the Kepler mission of NASA. So one could say that more missions means more exoplanets found in future. And which also tells us more about our own place in the universe and our own chances of finding life, probably perhaps outside our Earth. This is just a simple picture where you can see some beautiful exoplanet forming regions. These are all data processed images from latest missions. So just to give you a scale of our own solar system, from this you could actually see different planets in our own solar system, from Mercury to Neptune. You could look at the scale of the sizes here. And generally, exoplanets are classified using this sort of scales. So you have Neptune-like exoplanets, super Earth, which is much more massive than Earth, but lighter than Neptune and so on. Then the terrestrial planets like Earth or Venus. Then the gas giants like Saturn and Jupiter. Then the icy giants like Neptune, Uranus and Neptune and so on. So this is the way you classify different exoplanets. And there's a lot of new exoplanets being discovered these days. These are all potentially habitable exoplanets in terms of its conditions, life-sustaining conditions and so on. And you could see there are various candidates some of them very far away from us, many, many light years away, but still having a very interesting sort of conditions similar to that of Earth. So just to give you a brief introduction to asteroids, they are just huge lumps of rocks orbiting in space, and they contribute to the geography and the population of the solar system in a considerable way. And some of them contain huge amounts of metal and minerals and so on. So here you could actually see a picture of different asteroids of different sizes and shapes and so on. So asteroid belt is an important part of our solar system. Here, all these yellow dots you see here are asteroids. You could see loads of asteroids between the orbits of Mars and Jupiter. It's a big cluster of objects, and you could see how populated our solar system is if we look closely. So this is the first interstellar asteroid which came to our solar system recently, a few years back. The cigar-shaped object came from a different stellar system altogether. You could see the orbit of this body, which came from a different stellar system, came to our inner solar system, and then again sort of going back to a different stellar system. So you could see a hyperbolic orbit here, which is not bound to the sun, and this was our first interstellar visitor. So why do we study these objects? That's a question many people ask. So some of these, one thing is it's very fascinating and interesting to study any object in this solar system or any object in cosmos. But if you look at it in a more practical sense, it even impacts our own safety on this planet. So many asteroids are near-Earth objects. They are in nearly circular and low inclination orbits. And calculation of Earth impact probabilities are of high relevance when you have to calculate what frequency in which these objects are sort of possible to collide with Earth. So we study size distribution and frequency analysis, and these things are constantly done and calibrated it to sort of forecast the risk factors from these bodies. So there's this very strong school of thought amongst astronomers that our own bigger cousins like dinosaurs got extinct because of an asteroid hit about 65 million years back. And so it could actually mean that some of these killer asteroids are able to kill some big species and on our own planet. And this has happened in the past. This might look like a funny scene from a Hollywood movie, but this is not very far from reality. If you look at the past in which Earth has been bombarded with different bodies, so this is a real meteor crater in Arizona in US called the Warrier Crater. And this is a crater with about 1 kilometer diameter. And this was created by a body from outer space. So it collided with Earth and produced this crater. So there's this very interesting event called the Tunguska event. So I'm just giving you a brief background to the impact risk from some of these bodies. So this Tunguska event was actually a small rock which came from space, and which actually had a huge blast in a big forest in Siberia in 1908. It actually managed to sort of flatten a whole forest in Siberia, and luckily because it was uninhabited by humans, there was no casualty and stuff. But it actually showed the impact and the power of some of these objects, how much of destruction it can cause. So this is just to give you the scale of some of these objects. So this Tunguska impactor is almost the size of a modern jet plane. And this Warrier Crater meteor is much smaller than that, but still managed to produce a big crater. So we used to think that some of these events were kind of rare, but now these ideas are changing constantly. So this was a meteor strike at a city called Chelyabinsk in Siberia in Russia in 2013. So there's this small rock from space, a bolide, which actually blasted in the air. This looks kind of beautiful, but it actually made a lot of destruction to loads of buildings around. A lot of glass pieces were broken and they were flying, and it injured a lot of people, and loads of people were hospitalized. So this is actually showing that how real some of these effects are from outer space. And this happened in 2013. And because these things depend on a lot related to probability and frequency and so on, the last two big events happened in Siberia because of the large area and the probability being higher depending on the area and so on. But if you imagine such a thing happening on a big city on our planet, then it's going to be a very catastrophic effect. So this is a map of impacts. If you just flatten the globe and look at all the impacts from different bodies of different sizes on Earth, you could see that Earth is constantly bombarded by bodies of all different sizes. So our Earth in itself is not in the most peaceful, safest environment, as it were. Many of these things we don't clearly notice or know because most part of our planet, a large area is occupied by oceans, and some of these bodies hitting oceans go unnoticed for the naked eye, or it doesn't make news. So this is a simple plot which actually tells us to don't worry about the details about the bolide energy and cumulative number and so on. Just to give you a takeaway message from this, it just says that what frequency these impacts happen. So these Tunguska-like impactors, which I discussed before, happens once every 100 years or so. And the Chelyabinsk-like impactors, which happened again in Russia, happened every few decades or so. So these events have frequencies. These are more frequent than we think. That's the main point. And just to give you a brief introduction to comets, comets are generally like dusty snowballs orbiting in space. And some of these bodies, when they come close to the sun, they start outgassing, and the sublimation happens, and some of these bodies show these beautiful tails. So it gives a coma and a tail. And here you can see a spectacular sun-grazing comet called Ikiyaseki. And some of these sun-grazing comets are quite unpredictable, but they are very spectacular when they come close to Earth. This is a very famous comet called Hale-Bopp. It came roughly around the time of 1997, 98, I think. I remember seeing it from a very rural place in Nagaland at that point. I remember my own mentor talking a lot about this comet and his own fascinating observations about this comet at that time, which again inspired me to really look into cometary science and pursue it even further. So these white arrows you see in the picture are these comets. So you could have short period and long period comets, and some of these comets, as you can see, they all orbit around the sun. And it actually shows what a populated place our solar system is when you look at bodies of all sizes. So some of these comets, especially the short period comets, they originate from a place called the Kuiper Belt. And this is a area which is beyond Neptune, with clusters of lots of small bodies there, a lot of icy bodies. And some of these long period comets, it comes from a place called the Oort cloud, which is even farther, much further, extends to about 1 AU, I think. And this is a huge reservoir of icy bodies and comets, and they populate our solar system when some of these comets in the Oort cloud gets perturbed by these passing stars and so on. And the most interesting symmetry in this is the number of comets in the Oort cloud is roughly same as the number of stars in our galaxy. So it's about 100 billion comets in the Oort cloud, which is roughly the same as the number of galaxies in the universe. So there's a beautiful symmetry there. And this was the first interstellar comet, 2I Borisov, which visited our solar system a few years back. And this is our second interstellar visitor and the first interstellar comet. And you can see a beautiful picture of that here. And this comet Borisov, it actually just passed quite far to Earth, just came into the solar system and just went back to its own stellar system. not bound to the sun in a hyperbolic orbit, and we were able to observe it. And this actually shows how exciting some of these things are, because these comets and these interstellar visitors were totally unexpected, and we saw them coming instantly. Many of these things were predicted for a long time, but we couldn't see one in real for a long time. So it was exciting news. So we also think that there is a big school of thought amongst the people in the community that comets could also be like a source of large amounts of water ice for some of the planets, for some of the exoplanets as well. So could have been sources of water for our young Earth, maybe. It's possible. And organic compounds may have contributed to starting of life in that way. So in a way, Comet is also deeply connected with life in an indirect sense. So just to give you a brief introduction to meteor showers, meteoroids are produced when comets start outgassing when they come close to the sun. And these dust particles which are trapped in the ice, they generally come out and fall into orbits which are close to that of the comet. So, and these dust particles also orbit around the sun. So that's how a meteor shower is formed. So meteoroid streams, when they intersect the Earth, they burn in the atmosphere and due to this friction, and you could see bright streaks of light or something, what you call as shooting stars. It's a spectacular, magnificent thing to look at when you see some shooting stars on the sky. So there are also practical aspects to studying meteor science. It's not just that they are beautiful and elegant and grand things to look at. There are also practical worries when you have very strong meteor showers. So meteor storms are very spectacular to watch, but at the same time, they can also cause threats to satellites and astronauts. Even particles as small as 1 micron could actually pose some problems to the electrical circuits on satellites and so on. So there was even a Kyoto mission. I remember there was 1 or 2 missions which got affected due to meteor hits. And generally, they say that particles of the size of even as small as 1 millimeter can cause mechanical threats to solar panels and so on. So it's important to do these threat estimations and densities, and these studies actually help us to make our satellites and spacecraft safer. So here you see some simulations where we try to sort of understand how these stream particles evolve and how some of these particles can intersect the Earth, how they can intersect the satellites and so on. So this is actually a simulation exercise done from ESA, the European Space Agency. There is a mission called JUICE, which stands for Jupiter Icy Moons Exploration, I think. And they do a lot of simulation trying to understand these annual meteor showers and how they affect the environment of these trajectories of these satellites and space missions. So you could see this, the spacecraft is actually amidst a very crowded region in terms of small particles. So these clusters of meteoroid streams and meteoroid particles is all over the place. So it's actually quite a challenge to actually navigate so that it doesn't intersect any of these very risky, threatening kind of meteoroid streams. So certain years we see meteor storms which are absolutely out of this world. So this is one example where in 1833, there was a Leonid meteor storm. Obviously at that time, there was no other technology to record it, but there is a very famous wood engraving done by some monks, I think, of this Leonid meteor storm. And the present estimate shows that it was about 1 million meteors per hour. So it was almost like raining meteors through the sky. There are even eyewitness accounts saying that one could see some meteors even when the sky was a little dim during the day. So that would have been a spectacular event if that's true. Nevertheless, the night sky, they said it was almost lit like daylight. So it actually shows how beautiful and bright the sky would have been. So some of these things, although this happened in 1833, doesn't mean it can't happen again. So some of these meteor storms and meteor storm forecasts is a very exciting area of study. And many of us do simulations and try to forecast some of these things for future years. So there are a lot of interesting stuff to look for, especially for the youngsters in this room and the students in this room. It's a very exciting time to join the small body solar system community. A lot of interesting stuff coming up. There is this asteroid Apophis, which is going to come close to Earth on 2029. For a little while, people were very puzzled and scared that it almost had 3% collision chance with Earth. And Apophis is, I think it's about 400 meters or so, 40 meters or so, which would have caused a strong impact. And luckily, the present estimates and the present calculations show it's going to safely miss the Earth. But this asteroid is going to come again in 2036. But the most exciting fact is that the Earth is going to nudge this asteroid in a certain way that it's going to come even farther. It's going to even miss by a bigger distance when it comes back in 2036. So a lot of interesting stuff to look at. The Plato mission from ESA, the European Space Agency, is a mission dedicated for exoplanets. A lot of new exoplanets is going to be discovered in this Plato mission. And some of you would have heard and seen images from the JWST, the James Webb Space Telescope. Some of these observations, images have been coming in the press, and they are fantastic. And there are a lot of scope for citizen science projects for asteroids, comets, meteors, and exoplanets, and so on. So there are a lot of data mining which you could do. You could identify some of these exoplanets using light curves. And you can also play around with exoplanet orbits and try with different initial conditions and how it evolves and so on. And latest AI and image processing things combined together would also help you to analyze observational data in new ways. So it's an exciting time. I encourage youngsters and students here. One of the reasons why we conduct these kind of lectures, and also as a homage to the gentleman in whom this lecture is considered like a memory, is to bring new people, new brains, fresh brains with fresh ideas to this field. So that's the whole idea about this exercise. So you're welcome to ask me any career guidance questions and stuff. These days, I'm sure most of the other questions about science and stuff you can Google up and you can find on internet very easily. There are plenty of sources on YouTube and Google and so on. But if you have any specific career guidance, questions or advice, please feel free to contact me. Thank you.